Hey everyone, welcome back to this channel and I hope you are doing great. Today we are going to see the chessboard and queen problem, and the description states that your task is to place 8 queen on a chessboard so that 2 queens are do not attack each other, and as additional challenge each square is either free or reserved and you can only place queen on the free square, and however the reserved square do not prevent queen from attacking each other, and we have to print the total all possible way to place queen on the chessboard. Okay, and for free place we have given dot, and for reserve we have given asterisk. Okay, so our objective is to place 8 queen on a chessboard such that they do not attack each other, and there are some free slots and there are some reserved slots, and we cannot place the queen on reserved slots. So let's say I'm breaking into the simple one. Let forget about the reserved slot. Let's say I have all my grid is empty. Okay, so how can we place a queen on a chessboard? So let's say if I am placing a queen over here, then where can I put the another queen, and where I cannot put the other queen? So if I am placing a queen over our column 3 and row 4, then we cannot place the next queen in row 4 or column 3 or the diagonal of 3 is to 4. That would be on this diagonal and on this diagonal. And if I place the another queen on this either same column or same row or diagonal 1 or diagonal 2, the both queen must attack each other. Okay, so we cannot, if I place a queen over 3 comma 4, then we cannot put another queen on blue line or green line. Okay, so the problem is pretty easy. We just have to put a queen. We just start from 0 comma 0, start adding a first queen over here. Either we can traverse on row or we can traverse or column. For my convenience, let's say I am just starting from top to down, that is I am traversing on row. So let's say I am placing my first queen over here. Okay, so what the next? I have to place the another queen onto the next row. Okay, so can I put over here? I just check, can I put over here? No. So can I put over here? No. The 2 queens must attack each other by diagonal, so I cannot place over here. So can I place over here? Yeah, I can place my second queen on 1 comma 2. Okay, after that I just go to the next row and column 0 and ask to myself, can I put my third queen over here? No. Okay, can I put my third queen over here? No, the diagonal are must coincide. Okay, so no. So can I put my third queen over here? No. So can I put my third queen over here? No. This is a unattacking position from previous queen, so I can put my queen over here. Okay, and after that I just go to my next row. So again I just check, can I put over here? No. Can I put my queen over here? Yes, this is a free slot and no any previous queen attack at this position. Okay, so I can put my fourth queen over here. Okay, again for the next row I just check, this is not a good place, this is also not a good place, this is also not a good place. For this, at this place, yeah, this is a good spot, so I can place my fifth queen over here. Okay, and start going further down and just check, is this my good spot? No. 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 And just check, and this is the diagonal of this. Yeah, I cannot place also over here. I place my queen over here. This is the diagonal of second queen. Okay, I cannot allow to place my queen over here, so I just place my queen over here, and this is a good slot for sixth queen. So I come back to the next row and just check for this is not a free slot, this is not a free slot, this is not also not a free slot, this is also not a free slot, and this is also not a free slot, and I think this is the free slot. Yeah, at this point no queen, any previous queen attack at this place, so I place my 7th queen over 6, 5. Okay, so again I coming back to the next row and start from 0 column and just check this is a free slot, not, this is also no, this is also no, this is also no, this is also no, this is also I place, no, I cannot place. So can I place over here? No, I cannot place. The diagonal of the 7th queen is attacking over here. So can I place my queen over here? No, I cannot place my. So here we can see I have no any slot over here to place my 8th queen. Okay, so what can I do? I just have to return onto the from the beginning and just start from, let's say I'm taking the blue color, I'm just start here placing my first queen over here and just start from the next row from 0 column, again from the second row from the 0 column, and so on and so on. And we just have to find, whenever we find out we can place all the queen on the chessboard, we just increment my answer by +1. Okay, so let's say I have a grid 1, 2, 3, 4, 5, 6, 7, 7 and 8. Okay, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so let's say my queen is on 3, 3. Let's say I am taking another position. Let's say my queen is on 2, 3. Okay, so after placing a queen, how many another position we cannot fill the other grid? Okay, so if I am placing a queen 2, 3, this is my x, this is my y, I mean this is my row, this is my column. Okay, so we cannot place another queen on a same row. So we cannot place, if I am fixing my row, whatever the value of column we cannot place. This is my case 1. Okay, and also we cannot place another queen on a same column, that is in my case 2. We cannot place, if I am fixing my column, that would be 3. For any value of row we cannot place another queen. Okay, so and in my third case, what would be for the diagonal? Okay, we cannot place another queen on a same diagonal which coincide with 2, 3 queen. So how can we get this number? If we look closely, what is the 2 plus 3? 2 plus 3 would be 5. What would be 1 plus 4? 1 plus 4 is also 5. And what would be the 0 plus 5? 0 plus 5 is also 5. So if any position have its row plus column would be the same to the row plus column of my queen, that there is a much chance two queen attack each other. So we cannot place where the row plus column is equal to 5 for this particular case. Okay, and for this diagonal, how can we find that? So if we look closely, what is the 3 minus 3? That would be 0. What would be the 2? No, I just take 2 minus 3. For case 4, what would be the 3 minus 2? I am just take a difference between row column minus row. What is the 3 minus 2? That is 1. If I add 8, then what would be the overall sum? 9. Okay, again for this 1 and 2, for column minus 2, what would be my difference? 2 minus 1, that would be 1. If I adding 8, the overall sum would become 9. So in my fourth case, if column minus row plus 8 is same with any another queen, then both two queens are attacked each other. Okay, so this must be not equal. I am finding all the place where my another queen can't be placed. Okay, if my c minus r plus 8 is equal 9, then I cannot put another queen. Okay, so and here also given a fifth case, some points are reserved. So in my fifth case, if any queen that let's say my grid value I comma j is equal asterisk, okay, also we cannot place the queen on that place. Okay, so I have 5 condition where if a previous queen have placed, then we cannot place at these 5 condition. Okay, if a place satisfy this condition, then we cannot place my current queen over there. Okay, now the next problem is how can we find all the way. Okay, so in my example I just check for this, then with respect to this queen I just place my next possible place, and again, and when I traverse whole my grid from 0 to 7 in the row, then I just trace back to the previous one and just find the next place. Okay, for this there is no any next place, so again I just traverse back to my previous row and just find out what would be my next place. If I cannot find, then again I just check for my next place. So in here I just find out my next place. This is the diagonal of this, this is the diagonal of this, this is the diagonal of this. So I can find my next place over here. So I just mark it as a green. So I can find my next place over here. Okay, so after finding my next place over here, I just go back to the next row and just check for my next where I can place my next sixth queen on the chessboard. So again I am traversing from the 0th column. This is not a good place, this is also 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 not a good place, because columns are matching with previous one. Okay, and here this is also not a good place, because now I can find out, yeah, this is not also not a good place. The first queen is diagonally from this place. Okay, now we can also not, this is also not a good place, and again this is not also a good place, because the diagonal and the columns are matching from the previous one. Okay, so we cannot place the further. So again we traverse back to the previous one and check with this is a possible case. Okay, then again I just iterate into the further column. So is this a good place? No. Is this a good place? No, the diagonals are attacking each other. So is this a good place? No, columns is and this is also not a good place, and this is a good place. So I can just place my queen over here and just again traverse back to the next. Whenever I am able to put my queen on a row, I just have to traverse to my next row, and when I am not able to put my queen on a row, I just traverse back in the previous, such that I just traverse for my 0th, I just traverse my 0 to 7. When I am completing, when I put my queen onto the 7th column, and after that there is no any case, then I just return my answer. Okay, now coming to the time complexity, we just recursively, when I am just iterating the column 0, I just recursively call for the next row, then again the next row, then again the next row. After that I just traverse back and again go to the next row and next column, and again call for the next row and next row and next row. That would be the n, then also for n minus 1, also for n minus 2, and also for n minus 2, and also for and so on. Okay, and overall my n is 8. Okay, so the overall time complexity would be n, then n minus 1, then n minus, also for n minus 2. Okay, and so on. So the overall time complexity would be n factorial, that would be 8 factorial, that would be constant. That would I can consider it as a constant. So my time complexity would be big O of 1, that would be my 8 factorial at all the time. Okay, now coming to the code part. So first of all I have to take the input of grid. Okay, I call it chess, and the size would be 8:8. Size would be 8. Okay, after that I have to take input of this, and size would be 8 I plus plus, and after that again I have to take input of j is less than 8 and j plus plus, and take input of chess I and j. After taking input, I just initialize my answer variable, and after that for checking all the cases I have to just initialize my boolean vector, vector bool for occupied column, and the size would be 8, vector bool for the diagonal one, and the size would be, and this would initialize as a false. Okay, and size would be, what would be the size of my diagonal element? Okay, let's say I am taking as a maximum case, let's say it is 8 plus 8, 7 plus 7. What would the total sum is 14. I am making it as a shape, that would be 8 plus 8 would be 16. So I just make it as a 16. Side would be 16 and it is false. Okay. Again I am taking a extra vector for bool for diagonal 2. That would be 7. Let's say it is 7 and 7 0, so 7 minus 0 would be 7, and if I adding 8 that would be 15. So again the size would be, for safe case I am taking 16 as a false, and I do not have to worry about the row, because if I am traversing in a row there is no any chance that two queens have same row, because whenever I put a queen I just traverse to my next row. So whenever I put my queen, that do not coincide with the same row with the previous row. So if I am traversing in a row, then I don't have to check the condition 1. If I just have to take care about the condition 2, and if I am traversing on column, I don't have to check about the case 2. I just have to take care of case 1. Now after that I just have to call my function, and I have to just pass my first row from where I have to start, and after that my chess grid, after that my occupied column, after that my diagonal 1, after that my diagonal 2, and my after that my diagonal 2 and my answer variable. Okay, after that I have to only print out my cout answer. Okay, so in my function I just initialize my row, taking parameter as a row, and vector char ampersand of chess. After that I have to just take occupied column with passing by reference, and vector bool for diagonal 1, also vector bool for diagonal 2, and last my answer variable. Okay, and first of all I have to check my base condition. So how would we check that? If we can see that we are just traversing in a row and my idx is starting from 0, and if we are able to place a queen on a row, we can just traverse on to the next row, and so on and so on. And if we are not able to place any queen on a row, we just traverse back to the previous row, and just if my previous queen at this place, I just have to place onto the next column, and just check if it is a possible case or not, and so on and so on. And if we are able to place the queen, then we are just again traverse to the row, and so on and so on. So if I am at my 7th row, and if I am able to place my queen at any place, so what is the meaning of it? The meaning of it is I just have to place my all previous queen on the each row, and I'm also able to place my last queen onto the 7th row and just increase my idx equal by 1, that would be idx is equal to 8. That means I have completed one way. Okay, for this, if my row would be 8, then I just have to increment my answer by 1. That means I just have to find one way. Okay, and after that return from there. And if not, then I just have to traverse from column 0 to column 1 till we didn't find a particular place. Okay, so for this I just have to initialize a column variable initializing from 0, and column is less than 8 and call plus plus. Okay, and we just have to check all the conditions. Let's say if my chess if my that particular row column is reserved or not. That means if my row or column would be have asterisk or not. Okay, or if my occupy column given me true or not. Okay, that would be call, and for my diagonal one I just have to check my row plus column, and for diagonal 2 I just have to check row minus column plus 8. Okay, and if the if condition is satisfied, I just have to continue, and after continue I just have to find my place. So first of all I just mark that column as a true call. Also I have to mark all my diagonal. I'm reserving for that particular diagonal one r plus column, and also for diagonal 2 r minus call plus 8. I'm all marking it as a true. Okay, after that I just call a recursive function. That would be I just jumping over the next row and chase, also then call, then diagonal 1, then diagonal 2, then my answer variable. After that I just have to traverse back, mark it as all false. Okay, I have completed my code part. Let's say if it is working or not. Now it is working fine. It is 65. Yeah, it is, the output is 65. Now let's try to submit this code and check if it is working or not. Okay, A. Now this is totally working fine and it is accepted. So if you like this content and if you want more and if you really enjoyed it, then please like this video and subscribe to this channel and share among your friends. I will be appreciated, and if you have any query, any suggestion, then please reach me out into the comment section. Bye bye, take care, happy code.